Hello, Math 7 students. This is Open Up Resources Unit 2, Lesson 6, Using Equations to Solve Problems. Since this lesson is about using equations, we do need to practice writing equations. So this is your quick pull warm-up that you'll be entering into your calculators. We have a table. It says write the equation for the relationship seen in the table. You have a few more seconds to get this entered. Online students, please pause the video long enough to give yourself a chance to think about and write down what the equation should be. All right, there should have been enough time now. You should have paused the video long enough to have your equation written. Students in class, we have all but one correct answer. The student who did get it wrong, I feel like they got it wrong, mostly because they didn't read the question. We are asking for the equation, not the constant of proportionality. You do need to find the constant of proportionality to write the equation. But once you find that constant proportionality, you do need to write the equation. So here were the student responses in class. You can see x times 3 equals y is acceptable. Reversing that, 3 times x equals y is acceptable. And reversing that to y equals 3x is also acceptable. All three of those are equivalent to each other. That's why as soon as I highlighted this one as green, the other is highlighted green as well. This is the correct constant of proportionality, but it is not an equation as was instructed by the directions. It says write the equation. So the first thing that we should be doing is asking, and this is the best place to look, how does a 1 change to a 3? We multiply it by 3. And we can check to make sure that that happens everywhere else. 2 multiplied by 3 is 6. That works. 3 multiplied by 3 is 9. 9 multiplied by 3 is 27. 0 multiplied by 3 is still 0. And negative 1 multiplied by 3 is negative 3. So now that I know that constant proportionality, that's when I start to generalize it and say, okay, well, what if I have an x in the column? Well, the x would still be multiplied by 3, and that would give me the y, and that tells you exactly what that equation is. We take that x, we multiply it by 3. It gives us what's in that right-hand column, which is y. And again, the different ways that this can be written is 3 times x equals y. If you type in your calculator simply 3x, the calculator does change it to 3 times x. You shouldn't be alarmed by that because 3x does mean 3 times x. And you can also start it with the y equals the 3x. All of these are the same equation. They might look a little bit different because the order that they're in, but they're all the same equation. And now we're going to switch gears and look at the Unit 2 Lesson 6 warm-up. It's a number talk. And we want to do quotients with decimal points without calculating. That means we are not using our calculator. I want you to order the quotients from least to greatest. Go ahead and work with your groups, talk about it. We're not actually typing these into our calculator. We're not actually doing the long division. How are we going to figure out which ones are going to be the bigger ones and which ones are going to be the smaller ones? Talk with your groups. We'll come back in about 60 seconds. Ready, set, go. In order to talk about these, I'm actually going to label them A, B, C, D, just to make it a little bit easier to talk about them. All right, looking for volunteers now. Which one is going to be the least, the smallest one? Siley. A is the smallest. How do you know? Because what? It has a decimal. So that one's going to be the smallest because it has a decimal. The what? Sorry? Yeah, we are dividing. Does that maybe make you rethink your thought there? The 0.07 or the 700ths is the smallest number. That is a true statement. But because we're dividing, notice that our divisor, dividend, our dividend, I always get those mixed up, our dividend is the same throughout. The only thing that's changing is the divisor. And the only thing that's changing in the divisor is the decimal place. Oh, they did change one of them. Ooh, that's sneaky. That is so sneaky. Okay, that might change things a little bit then, right? Okay, so knowing that if we just focus on A, B, and C, let's just focus on there for a minute. If we're just focusing on A, B, and C, When I divide by smaller numbers, what happens? When I divide by bigger numbers, what's happening? Carter. You got it. And I love the use of that math vocabulary, quotients. If I have bigger divisors, I'm going to have smaller quotients. And if I have smaller divisors, I'm going to have bigger quotients. So just focusing on that A, B, and C, we'll get to that D in a second. Which one is going to be the least? Which one is going to be the smallest? Let's go back to Siley again. B is definitely going to be the smallest because we're dividing by a bigger divisor, which means that the quotient is going to be small. And now, which one is going to come next? Which one is going to be that middle one? Danielle. C is going to be next. Because C, that number got a little bit smaller, that divisor got a little bit smaller, which means our quotient is going to get a little bit bigger. And A, that leaves us here, it's the smallest divisor, which means it's going to be the biggest quotient, right? Now, where does D fit into all of that? Which of these up above is the most similar to D? A, B, or C, which is the most similar to D? B, because we at least have the same divisor, right? So now let's reverse what Carter was saying earlier. Because now we have the same divisor, it's the dividend that's changing. So if I have a bigger dividend versus a smaller dividend, which is going to produce the bigger quotient? Turn and talk to your tables. Which one is going to produce the bigger quotient? Okay, again, we're trying to compare B with D here. They are both being split into the same number of pieces. So which one is going to produce the bigger quotient? 42 and 6/10 split into 70 pieces, or 426 split into 70 pieces? Which one is going to be bigger? Raise your hand if you say it's B. Raise your hand if you say it's D. Yeah, you're correct. So that means just slightly bigger than B is going to be D. So let's make that look nice and neat. B, and then D, and then C, and then A. Okay, the next question says, place the decimal point in the appropriate location in this quotient. We have 42 and 6/10 divided by 7. Where is the decimal supposed to go here? Talk with your groups. I don't want you to calculate. No using your calculators. Where is that decimal place supposed to be? Talk with your groups. Okay, and what are your thoughts? Let's talk about 2A. Where is that decimal place supposed to go? How did you answer this question since I didn't let you use your calculators? Let's hear some strategies. Seth. Do we? Yep. Do we move the decimal place over when we divide? Think about what that would look like if we're doing long division. So you're not actually doing the long division, but if we're doing the long division, where would that decimal place go? Does it change? Carter? You got it. Exactly right. So again, let's think about if we were actually setting up this problem for long division and we ask, can 7 go into 4? No. Can 7 go into 42? Yes, it can go in 6 times, and then where does that decimal place go to? It goes right up above where it already is. If we are multiplying using the standard algorithm, then we would have to count where that decimal place is and move it over the appropriate number of places. But when we're using division, we don't change that decimal place. And I think that what Carter did is a great strategy. We don't know 42.6 divided by 7, but we do know 42 divided by 7. And so 42 divided by 7 isn't going to be 60 or 608 or any of that. It's going to be just a little bit more than 6. So 6.0571. With that in mind, here's your ultimate challenge question. Use this, what we just did here, knowing exactly where that decimal place is going to go. I want you to find the quotient of 1. Not all. Just pick one. Find the quotient of one of these. We already know, right? We just need to know where that decimal goes. Let's go 60 more seconds of discussion here. Online learners, pause the video until you're ready. All right, the majority of students in class chose to do D, which is boring and lame because it is exactly the same. So that's why we're not going to talk about that one. I want to pick on a group who chose a different quotient to find. So remind me who had A? B? C? All right, we'll go with this group for C. Go ahead. So you didn't actually do the division, but you kind of set it up like this. 42.6 like this. And then you said, hey, I know where that decimal's going to go. Good. We need to make sure that our decimal is moved over appropriately. So now we're still almost asking the same question as before. It's just that our decimal has moved to a new place, which would mean it's going to be 6D and then all of that other stuff. So the decimal would move over one place. 60 and 8,571 ten thousandths. Yeah? 10,000,000. Yeah, 10 thousandths. Okay. That was a nice long 13 minutes of warm-up. Let's see if we can actually start into our lesson now. We are looking at this situation of concert ticket sales. Now, I'm going to give you some words of advice. Later on, it asks us to write an equation. But I think that waiting until the end to write an equation is a bad idea. I want us to write the equation early on because that's what this whole lesson is supposed to be about, using equations to solve problems. So let's write the equation early on. And this task really kind of takes away all of the baby steps that we've been used to when it comes to writing equations. We don't have tables to look at anymore. So I want us to still make some little miniature baby tables that don't have all of the details and all the information, but they'll help us think about this problem. So it says a performer expects to sell 5,000 tickets for an upcoming concert. They want to make a total of $311,000 in sales from these tickets. So step 1 says, assuming that all the tickets have the same price, what is the price for one ticket? What we're really asking here is we're asking for the unit rate. So talk with your groups. How are we going to answer that question first? And then from there, we're going to start setting up our little mini baby tables. How are we going to find that unit rate? Okay, now before you even start typing into your calculator, tell me your strategy. What are we doing to find the unit rate? Good. Should see a few more hands. Seth, get us started. We are going to be doing division. So 5,000 tickets divided by $311,000. And think about what this is going to be in the end, even without doing the calculation. Remember, this line right here means per, right? So this is going to be the tickets per dollar, not ticks. Tickets per dollar. Does that answer the question? Tickets per dollar. What is the question asking? Price per one ticket. Yep, so we need to rethink this. And this is where a strategy that I worked on with my other classes, and we spent a couple extra days on it, is going to be really helpful. Start at the end. And what I mean by that, it says, what is the price for one ticket? And so that tells me at the end of this problem, there should be a 1 for tickets. And the 1 should always be on the bottom. So if the 1 ticket is going to be on the bottom and tickets is on the bottom, that tells me that dollars is going to have to go on the top. So when I set up this problem, before I do any calculations, before I even look at the original information, I really set it up with the end result in mind. I want it to be dollars per ticket or dollars for one ticket, so I'm setting it up that way in the end. And now that I've set it that way in the end, now I can go back to the beginning and say, okay, in the beginning, that means that I need to have the dollars on the top, and I need to have the tickets on the bottom. So that would be our $311,000 on the top and 5,000 tickets on the bottom. This is our unit rate process. We want to now ask, okay, how does a 5,000 change into a 1? That's easy. We divide by 5,000. So what am I doing up here? That 311,000 is also going to need to be divided by 5,000 to keep these ratios equivalent. Good thing we have calculators. 311,000 divided by 5,000 is equal to, once you have it calculated, raise your hand to let me know. Online learners, this is an opportunity for you to also plug it into your calculator. Gabe, what did you get? $62.20 per ticket. Do we agree? Okay, sounds good. So this is our unit rate. Keep that in mind. We're going to practice unit rate a little bit more, but I do want us to not forget what we have done in the past with our unit rate. So how much will they make if they sell 7,000 tickets? Now, we can answer this question by using that unit rate. But I want us to do what it says here and use equations. So let's write the equation first. To set up the equation, I want us to actually make our little baby table. And here's what I mean. So you guys should be filling this out with me. We have tickets and we have dollars. And because we already found the unit rate, we have enough information in here that we know that one ticket will cost $62.50. We also, if we wanted to, yes? $62.20, thank you, good catch. 20 is a weird number to end on. $62.20, so my brain just didn't want to accept 20 cents. We also know that $5,000 tickets will cost $311,000. The reason why taking this baby step here and finding that unit rate is so helpful, because now when I ask the question, how do we go forward in this table, you can see it very easily. How does that one change to a 62.20? We multiply it by 62.20. Anytime I'm going to go forward in this table, I'm going to be multiplying by 62.20. So even though it doesn't ask us to write an equation, I want to show you just how helpful these equations can be. What variables do we want to use here? T for tickets and D for dollars? Will that work? So now I can write the equation that says, take the T, we're going forward in that table, so that means I'm going to take that number of tickets and multiply it by 62.20, and that's going to give me the grand total D dollar amount. And again, the reason why this is helpful is now it's saying, okay, what about 7,000 tickets? What do we do if we want 7,000 tickets, or if they're selling only 7,000 tickets. We're just changing that T amount to the number that it's telling us to change it to. So that changes to 7,000 times our 62.50, and that's going to be our new dollar amount. Do you have calculators? Type that in. You have the answer already? Oh my gosh, my brain does not like 20 cents. 62.20. Type that one into your calculator. 7,000 times 62.20. Peyton, you have it already? Super fast. Let's wait till a few more use their tools and get this typed in. It gives our online learners a chance to also get it typed in. Okay, Peyton, what did you get? Say that one more time. 400. Dollars? Perfect. So this is our abstract answer. D equals 435,400, right? Our quantitative answer would be $435,000, $435,400 for 7,000 tickets. Again, even though it did not ask us for an equation, setting up that equation sets us up for success. So question 3 says, how much will they make if they sell 10,000 tickets, or 50,000 tickets, or 120,000 tickets, 1,000,000 tickets, or X tickets? Answer those questions. Good thing we already wrote our equation, right? We're good to go now that we already wrote our equation. We know exactly what we're going to be doing. I want you to pause the video and answer just question 3. Don't move on to question 4 yet. Answer just question 3 with your groups, typing in all of those calculations. Give you about 90 seconds. So pause the video for about 90 seconds to get this done. Okay, we've paused the video, we have calculated each one of these, and we have used our equation, which is T times 62.20 equals D. And so if I have 10,000 tickets, that's very simple. I'm just replacing the T with the number 10,000. And in doing that, I get D is equal to, thank you for the hands, Dean. $622,000. What if they are selling 50,000 tickets? Again, we're taking that equation, and all I'm doing is simply replacing the T for the number that they have given us, which this time is 50,000. So 50,000 times 62.20 is equal to, thank you, Gabe. Like this, 3,110,000, like that? Yes, $3,110,000. You said that perfectly. And now these numbers are starting to get pretty big in our calculator, right? T times 62.20. Only now the T is equal to $120,000. Is this the one where your calculator gave you the error? Not the error, really. Were you able to calculate this one? Okay. Okay, so what you're seeing when you're seeing this in your calculator, let me type it in. The calculator is not actually giving you an error. It's saying that's a really big number. So we are typing into the calculator 120,000. I needed to add one more of these guys here. Times the 62.20. So times 62.20. That's not an error. I'm going to make it bigger so we can see it. What this means is here's the start of your decimal places, and we need to move the decimal place over that many times. This is actually scientific notation. If you haven't learned about scientific notation, hopefully you will soon. But again, what that tells us is, we'll write it down, 7.46 Is that what it said? 7.46 E6? And that tells us 7.46 times 10 to the 6th power. You will be learning about this in detail in math class next year. But all that really means is we're going to take that decimal and we're going to move it over 6 times, not 10 times, 6 times. That E6 means we're going to be moving it over 6 times. So 1, 2, I'm out of decimal places, right? Nope. 3, 4, 5, 6. So what do I fill those up with? Zeros. So what is that number then? We have 746, 0, 0, 0, 0. Looks like that's 7,460,000. Yes, ma'am. 64, not 46. Oh, 464 E6. So I need to come back. Oh my goodness, let's see. This is a great example of when I ask for how it's going. You guys tell me back when I first make the mistake, instead of waiting for me to continue on with that mistake for a lot longer. 7, 4, 6, 4, but we're moving it over 6 times. So 1, 2, 3, 4, 5, 6. So I'm going to annex in some zeros here. And that gives me 7,464,000. Like that, Siley? Yeah. So again, it's not an error. The calculator is saying that's a big number. That's hard for me to display. Some ways around that. We can actually make those changes here. Online learners, depends on the calculator that you're using, whether or not you can make those changes. But that would be in, we have to go home, option 5 settings, document settings, changing the float. Right now this is saying we can display 6 digits, which means that we can't get into the millions really if it's only displaying 6 digits. So if we change it to like float 8, then it allows us to make those calculations a lot easier. Wonder if it'll show up now. 120,000 times a 62.2. And now it showed it all, but it's exactly what we said it was going to be, 7,464,000, because we don't have to worry about not having enough digits. So again, for you guys in class, that's home screen, change your settings. So option 5 settings, option 2 document settings, make it at least a float 8. Float 8 should hopefully reduce some of those scientific notation answers. Yes, but we are fine with float 8. We don't need to go up to float 1 million or whatever it says. Yeah, just float 8 is fine. Once you have float 8 selected, hit OK. You'll have to retype in that calculation, but it will show from there on. All right, and we still need to answer, what about 1,000,000 tickets? So I'm completely out of space for that problem. So I'm going to come all the way down here. T times our 6220, only this time that T is changing to 1,000,000. Only it's tickets, not dollars. And you can type this into your calculator if you want to. But really, this is going to be $62 million? 200,000. Counting my own decimal places, making sure. Yeah, $62,200,000. And we're noticing a pattern here, right? So it says, well, what about for X tickets? That's just helping us write that equation, which we have already done. So writing that equation is going to be X times 6220 is equal to D. We can keep our T. I like using T for tickets instead of the very abstract X. X doesn't really tell us what we're doing at all. But again, tying this in to the next question. This is really important that we make this connection on how important those equations can be. Notice what's different about question 3 and question 4. Here we're asking how much money are they making if we sell these number of tickets? But now the question changes to, if they make this much money, how many tickets have they sold? How does our strategy need to change? Talk with your groups. How does our strategy need to change from 3 to 4? Okay, and now back to me. How does our strategy need to change here? Does it need to change at all? Okay, how does it need to change? Thank you for the hands. That means I'm still waiting for a few more hands. Peyton. Yes, that is true. And I want us to understand why we're going to change it from multiplication to division, like you said. And it all goes back to the equation. So return to this equation here. What's different is I'm telling you the dollar amount. So am I going to just take the T and write in the 379420? No, because it's not the ticket number that it's giving me. It's giving me the dollar amount this time. So I'm switching out that D for dollars to the number given, the $379,420. But I'm keeping the rest of that equation. So T times our 6220 is equal to $379,420. So what is our strategy now? It's exactly what Peyton said, but why is our strategy to divide? Because we're solving an equation. What's happening to T? We're multiplying it by 6220. How do I undo multiplying by 6220? We divide by 6220. And whatever I do to one side, we have to do it to the other side. And that gives me T equals. So yes, exactly what Peyton said. Our strategy changes. Now we need to do division. But why are we doing division? I want you to understand that we're just solving the equation. We're using that equation. We're just solving it for the variable T now instead of the variable D. And what did you get when you typed this in? $379,420 divided by 6220. Slightly? 610? You guys agree? Got the same thing? No? 6,100? Is that good? All right, 6,100 tickets. Now again, repeat that strategy and we're going to finish up here. How many tickets will they have to sell to make $5 million? Again, start with that equation. T times our 6220 is equal to D, but now the D, the dollar amount, is 5 million. So T times 6220 is equal to 5 million. What's happening to T? We're multiplying by 6220. How do I undo that? We divide, and whatever I do to one side, we do it to the other side. And I get T is equal to, first hand up I'm going to call on. Gabe? 80,395 and 90 cents, you said? 85? I want you to double check. I'm not saying you're wrong, but there shouldn't be a decimal if we're talking about tickets because we can't have a partial ticket purchased. So double check. 5 million divided by 6220. We all have calculators. We shouldn't rely on someone else to do the calculation for us. 5 million divided by 6220. We did get a decimal, didn't we? I don't understand why. Yes, Carter. We can't sell that partial ticket. I like that. I like that. That's a good practice for math practice too. Taking a number that mathematically makes sense but quantitatively for the story doesn't make sense. And then making it make sense for the story. So yes, the tickets would have to be 80,385.852 tickets. We can't do that. So how many tickets would that really mean that we would need to sell? 80,386 tickets. Yeah, good. Okay, we made it through one problem. That's it for today. We'll see you next time.